Hello everyone. Today I'm going to introduce the consistency mechanisms of the Agile Open Container, or AOC. The AOC ensures consistency from two aspects: device consistency and service consistency. This course focuses on the background and functions, working processes and operation processes of the two mechanisms. Let's begin with the device consistency mechanism. So what is device consistency? Well, device consistency is a function for maintaining the consistency between configuration data on the AOC and NEs. In other words, device consistency ensures that the AOC configuration data is the same as that on NEs. But why do we need device consistency? The reason is because the AOC can only accurately deliver configurations when the configuration data of the AOC is consistent with that on the NEs. Device consistency enables the AOC to quickly and accurately locate issues such as device configuration loss and errors. Next, when do we need to perform the device consistency operations? Normally, the configuration data stored in the AOC is consistent with that of NEs. However, data inconsistency may be caused in some scenarios. Example scenarios include when the AOC manages a device for the first time, a device is managed in a decentralized mode, or a fault is being diagnosed. In these scenarios, we need to use the device consistency mechanism to eliminate data inconsistencies. The AOC provides the device consistency mechanism to check and eliminate the configuration inconsistencies between the AOC and NEs. The mechanism contains three functions. The first is inconsistency discovery, with which the AOC queries and compares the configurations on a device and displays the configuration inconsistencies. The second is synchronization. This function synchronizes configurations from a device to the AOC to eliminate inconsistencies. The third function is reconciliation, which synchronizes configurations from the AOC to a device to eliminate inconsistencies. So how does the AOC implement these functions? Let's look at the process of inconsistency discovery. First, an application or engineer triggers the device consistency operations through the RESTful API or Web UI. Then the AOC delivers the operation commands to its device management module. Next, the module delivers a query packet to an NE according to its SND package through netconf or this CLI. After receiving the query packet, the NE sends its data to the AOC through netconf or the CLI. After that, the AOC compares the returned NE data with that in its database to generate inconsistency information. Finally, the AOC sends the inconsistency information to the application or engineer through the RESTful API or Web UI. Next, let's look at the process of synchronization. The first four steps of synchronization are the same as those in inconsistency discovery. However, in the fifth step of synchronization, the AOC writes the data of configuration inconsistencies between the AOC and the NE to its database after comparison. This synchronizes configurations from the NE to the AOC to eliminate inconsistencies. Let's move on to the process of reconciliation. The first four steps of reconciliation are the same as those of inconsistency discovery. Once again, the difference is in the fifth step of reconciliation, where the AOC delivers the data of configuration inconsistencies between the AOC and the NE to the NE through netconf or the CLI after comparison. This synchronizes configuration from the AOC to the NE to eliminate inconsistencies. Next, let's look at the operation processes of the device consistency mechanism. To discover inconsistencies, choose Configuration Consistency and then Device Configuration Consistency from the main menu. Select a southbound device and click Inconsistency Discovery and wait until operation status changes to Discovered. Click the icon in the Diff Status column to enter the Inconsistent Data page, where you can view the configuration inconsistencies. In terms of synchronization, choose Configuration Consistency and then Device Configuration Consistency from the main menu. Select a southbound device, click Synchronize and wait until operation status changes to Synchronized. To implement reconciliation, choose Configuration Consistency and then Device Configuration Consistency from the main menu. Select a southbound device, click Reconcile and wait until operation status changes to Reconciled. In addition to the preceding operations, the AOC also provides the policy configuration function, which is applicable to scenarios such as night polling. Policy configuration is easy to do on the AOC. All you do is choose Configuration Consistency and then Device Configuration Consistency from the main menu. Click the Policy Settings tab and enable Schedule Synchronization. Then you can set the synchronization start time and duration of polling and finally click Apply. We've now covered the device consistency mechanism. Let's now look at the service consistency mechanism. So what exactly is service consistency? Service consistency is a function for checking inconsistencies between the AOC service configuration and the AOC database configuration or NCE configuration. You may be wondering why the service consistency mechanism is still needed, since we already have the device consistency mechanism. Well, in some scenarios, users may only be concerned about whether a specific service configuration is correct. However, during routine maintenance, device consistency checks the full configurations to discover inconsistencies between AOC and NCEs, which is time consuming. In this case, you can use the service consistency mechanism instead. The service consistency mechanism provided by the AOC includes two functions: local inconsistency verification and remote inconsistency verification. Local inconsistency verification decomposes an AOC service instance, compares the configuration data with that in the NCE database of the AOC, and displays the inconsistencies. Remote inconsistency verification, on the other hand, decomposes an AOC service instance, compares the configuration data with that on the NCE, and displays the inconsistencies. Next, let's look at the processes of these two functions in detail. For the process of local inconsistency verification, an application or engineer triggers local inconsistency verification through the RESTful API or Web UI. Then the AOC delivers the operation commands to its service management module. Next, the module decomposes the service data into corresponding NCE data according to the SSP package of the service. After that, the AOC compares the service-associated data in its database with the decomposed data to generate inconsistency information. Finally, the AOC sends the inconsistency information to the application or engineer through the RESTful API or Web UI. Now let's move on to the process of remote inconsistency verification. Similar to the process of local inconsistency verification, an application or engineer triggers remote inconsistency verification through the RESTful API or Web UI. Then the AOC delivers the operation commands to its service management module. Next, the module decomposes the service data into corresponding NCE data according to the SSP package of the service and delivers a query packet to the NCE according to its SND package through netconf or the CLI. After receiving the query packet, the NCE sends its data to the AOC through netconf or the CLI. After that, the AOC compares the returned NCE data with the decomposed data to generate inconsistency information. Finally, the AOC sends the inconsistency information to the application or engineer through the RESTful API or Web UI. Next, let's look at the operation procedure of the service consistency mechanism. To perform local inconsistency verification, choose Service Management from the main menu. Select a service type and a service instance. Then choose Local Inconsistency Verification and then Local Inconsistency Verification, and wait until Local Inconsistency Verification operation status changes to Succeeded, Inconsistencies Found. Finally, choose More and then View Local Inconsistencies to view the configuration inconsistencies. The operation procedure of remote inconsistency verification is similar to that of local inconsistency verification. Choose Service Management from the main menu, select a service type and a service instance. Then choose Local Inconsistency Verification and then Remote Inconsistency Verification, and wait until Remote Inconsistency Verification operation status changes to Succeeded, Inconsistencies Found. Finally, choose More and then View Remote Inconsistencies to view the configuration inconsistencies. That's all for today's introduction about the AOC's consistency mechanisms. Thank you.